Okay, today's topic of discussion is stack data structures. Okay, so first of all, you have to know what is stack. Uh, Stack is a simple data structure used for storing data. In stack, the order in which the data arrives is much more important. Okay, you can take for an example a pile of plates in a cafeteria is a good example of stack. The plates are added uh, to the stack as they are cleaned and they are placed on the top. When a plate is required, it is taken from the top of the stack. The first plate placed on the stack is the last one to be used. That is the main usage of stack data structure. So how do you define the stack? A stack is an ordered list. So now I can write it. So a stack is an ordered list in which insertion and deletion at one end called top. That means the last element inserted in the is the first one to be deleted. What it is also named as also LIFO data structure or philo data structure. LIFO means last in first out, so we can write it LIFO, last in and first out. This is the data structure, last in first out data structure. Okay, so this is basically stack. I want to give you one example. Suppose this is a stack and suppose the elements are stored here in this fashion. This is the elements. Now this is the bottom of the stack. Suppose this bottom element is A, it is stored here. So this is the top address. Suppose this is the top. Suppose these are the array. So suppose this is 0, 1, 2, 3, 4. These are the addresses and top element is A. Now if you want to insert B here in the top of the stack, what should we do? We should increment top to top plus 1 because that very location you want to insert. Now top will point to this position after incrementing top by 1. Now we can insert B. Again it can be incremented here and you can enter the element C, D like this. So these are the top. That means top will always contain the address of the last element inserted into that stack, always. So this very operation is called push operation, right? So push can be treated as a function. That function that is you can insert an element push X. That means X can be inserted at the top of the stack. So what is the logic behind this? Top of the stack means top will be incremented first, then you can push the element into that stack. Okay, push, and you can suppose the top address here is 3. Suppose top is equal to 3 here. Now you want to pop element from the top of the stack. So D will be popped. How pop means D can be popped definitely from the top of the address, and the basic operation is you can directly for popping element just you do this top within this, top is equal to, that means top minus minus, that will give you the pop operation. That means actually top minus minus will give you the pointer to here. That means now the top element is C. If D is there, no problem. Now D is, for you it is a garbage value. Now if you want to push again another element, suppose E, then this D element will be overwritten by E, right? So that means in pop operation the most important thing is you just decrement top by top minus 1. That is the pop operation. There are some more, that means these are the important things. So what is the complexity of push operation? Definitely for inserting one element into a stack it will take order of 1 time. What is the operation for popping? It is order of 1 time, right? So every operation here for inserting and deleting push and pop operations are of order 1 complexity. So this is the important feature of stack operation. That means stack is used for only storing data. There are some things in some top operation will be there. Top means what is the top element? That means in some book it has been written that it is a peak operation. Peak means you just take the element from the top, take the top element, but don't pop the element. Pop means the top address will be decremented, but here the peak operation or for top operation only the element from the top of the stack will be accessed. This is the top operation, right? And here there are another two operations, that is empty stack. Empty stack means is the stack is empty. Initially suppose that I will go through some. If the stack is, or suppose the array is taken as a stack, and suppose there are 10 places and the already 10 places has been occupied by 10 elements. Now 11th element you want to push, that means some overflow will occur because no storage spaces are there to push the 11th element, so error will be coming. And suppose in the array no elements are there, but if you want to access the top element, that means empty stack. So there are some more operations, that the full stack operation and empty stack operations, these are also the operations, but it will, the operation of this is also complexity is order of 1. These are the operations that I am giving you one example, then it will be clear to you. um, Example is there. What is the array? There are two types of implementation. That is array implementation, and including this array implementation, there are one thing that is dynamic array implementation, and another thing is linked list implementation. In this lecture, I want to tell you only the array implementation. How do you do this array implementation? That's I am giving you one example. You see this. Suppose int array, suppose this is 10, right? Now for array, as the number of element in the array to be inserted is 10, so the address is from 0 to 9. Top will be initialized to -1, right? What does it mean? Top is equal to -1 means basically it will give you the empty stack, right? This is very clear to you. Top is equal to -1 means empty stack. If it is positive up from 0 to 9, then it there are at least one element actually. So top is equal to -1 will imply the empty stack, right? So I am not writing all the coding things. So in the push operation, what is push operation? Push x means within this function you have to do this. Top is equal to top plus 1, that is top plus plus, and a top that I have told already, a top will be is equal to x. This is basically push operation. And what is pop operation? Pop operation is basically within this you just write top is equal to top minus 1. This is the pop operation, right? So now if you see this, in this scenario, if you write, I'm giving you one example. If you write, suppose this is the array, 0 1 2 3 4 5 6 7 8 9 7 8 9. These are the 10 places for this is an integer array. Suppose this is the integer array, and now the operation is push 3. Push 3 means, you see this, initially top is minus 1. Now top will be incremented to minus 1 plus 1 means top will be here, and 3 element will be inserted here. Now again, suppose again the operation is push 10. Then again the top is pointing here initially, so now the top will be incremented to top plus 1, then 10 will be placed here. Suppose again you are doing push operation, that is 7, then top will be incremented to here, top plus 1, that is 2, then 7 will be put here. Now we are doing pop operation. Suppose pop operation means this, pop operation means you see this top will be decremented to top minus 1. That means basically it will, now the top will point to this address. That means now for you 7 is a garbage value, because top will address the very location it is 1, so it is a garbage value. Now again you see this, suppose again push operation is coming, that is push 8. Then what will the push operation? And you see this top will be incremented by 1 by this operation, so and this 7 will be overwritten by 8, right? This is the way you can store that. That means this array is there, you can definitely randomly you can access any element, but this array actually can be used as a stack, where from one end you can push the element or pop the element. This is the main property of stack here, right? Now I'm writing the now one thing is there, I'm writing the almost the C code of for this push operation. You see this int max size int top is equal to -1. Now it is close to sorry, int a max size. This is the array. Before that, this max size can be defined. Before that, there is a macro you can define like this. This define max size, right? Define max size, then int a max size, int top is equal to -1. Now write the push operation. Here you see this, when you are doing the push operation here, int x, I want to write here definitely what should be your, you can directly write a plus plus top is equal to x. What is mean? Plus plus top means it is pre-incremented, so top will be pre-incremented to top plus 1, then that top plus 1 position, in that top plus 1 position x will be inserted. Now you see this, what is the drawbacks here? If the stack is full, then the last then the x element cannot be inserted, so it will give you some error. So to overcome that runtime error, you should write a verification here. What you should write? If top is equal to max, that is the max size. What is the max size? Minus 1, because if there are 10 elements, indices are from 0 to 9. So if it is max size, this is underscore, right? This is max size minus 1. Then you can write printf and error message. Error. What is that error? This is overflow and return. That means basically you see this, if this checking is there for every push operation, then it will never go to that situation where the overflow will occur. That will give the error message. So though there will not be any runtime error. So you have to write in this way the push operation, and the same way pop operation can be written here. You have to write if, what you should write, if top is equal to minus 1, then printf error. What is the error message? No element to pop, right? And return. That means it will never go to that situation where that top minus will occur. It cannot go to pop minus 1, because if it is top, that means this is basically working as a sentinel. This is the bottom of the stack. That means you can never go to below this top position, right? That's why this is there. So now within this, you can run that means this is almost a C code, and you can directly with the help of array, you can implement a stack very easily. Okay. Now I want to show you something. Now you see this, this is the already you have you know this, how the structure can be defined. That now you see this carefully. Just wait for some time, there is a problem. See this, define max size is equal to 10, suppose, and this array stack struct array. That is basically stack is an abstract data type. So this abstract data type can be defined in this way: struct array stack, in top, in capacity, and in star array pointer. And now you define this. What is the size? Create stack can be created, and all of you are knowing about this stack. Array stack star is malloc, right? And capacity will be the maximum size, and its top will be definitely -1, And what is the size of the array? That you already know, malloc this into size of the int, right? As it is the integer, you are dealing with the integer. Now you see this, there is a condition, if not s array, that means now elements are there, that means return null, right? Now there are, you see this, some functions are there defined here. Int now you see this is empty, this is empty stack. How is empty stack can be checked by return stop is called, if the top element is -1, you can return that the stack is empty. Full stack means if the top element is capacity -1, means that I have told is max size -1, that as we are implementing the array, then you can declare that the overflow will occur, no more element can be inserted or pushed, right? Now what is the push operation here? That before going to push operation, you see this, you have to check whether the stack is full or not. I have told already. Then stack overflow will occur. Else you can store the data on the top of the stack. You see this plus plus, that means pre-increment the top address, then that in that position data will be stored here, right? Again the pop operation means you have to check for empty, whether the stack is empty or not. Stack empty means it will be checked that whether that top address is -1 or not, right? That stack is empty, otherwise this array will be stop minus minus. It get to be so with the help of abstract data type of stack, in this way you can implement. Thank you for watching this, and see this video carefully and repeat. If you don't understand somewhere, repeat this video once again, possibly it can be understood by you. Okay, thank you very much.